So how about for the reactive system? Okay, if the system involve a reaction process, so the delta, it will involve the heat of reaction at constant or at desired temperature and pressure. So the exothermic is based on the exothermic and endothermic. This a value for the exothermic. That means we release the heat. So the value of heat of reaction is in a negative. If we have positive value, the process is endothermic or absorb the heat to the system. So the value of heat or specific heat of the reaction is depend on the stoichiometry. Okay, example, we have A plus equal to, so to C to produce C plus D. Or if we have 2A plus 2BB equal to C, or maybe, okay, example here, the heat is -6, so it turns to -12 because we have 2 times from the given. So the value will be depend on the stoichiometric equation and also the depend on the state of aggregation. So we have the different value of the specific heat reaction of the reaction. If we have the state where the example for water in liquid and gas, it will have the different value. Okay, this is the summary to calculate the heat of reaction. So the heat of reaction will be calculated from there, whether if the process is combustion, we may use the combustion here times the stoichiometric coefficient, or it can be based on the formation, or we can use this, and then finally we can determine the standard heat of reaction or the specific hot heat of reaction. And then we also should determine based on the heat extent of the reaction to determine the heat of reaction. Okay, let's take a look on the example. Okay, these are the overall. So we start with the material balance and then choose the reference state. Usually we can choose at 25 degrees Celsius and 180 M because most of the enthalpy calculation is determined at this temperature and also the pressure. Okay, the single reaction. Okay, for the single reaction in a continuous, we may calculate the extent of reaction that you may refer to the previous part, how to solve the reaction or the reactive system if involved in the system. So we may consider to calculate the extent of the reaction and then prepare the inlet or the enthalpy table as we prepared for the energy non-reactive previously. And then we may calculate the enthalpy as well. Finally, we can get the enthalpy from this. Consider on the extent of the reaction and also the standard of heat of reaction by consider the product minus the reactant. Okay, if involve the heat of formation, okay, this method preferable when there is a single reaction or the value of delta H of the standard of the heat of reaction is not readily available. The same procedure, we complete the material balance and then choose the reference state for the specific enthalpy calculation. Usually we can use at 25 degrees Celsius and 180 M, but based on the element for the heat formation method, we consider based on the element. And then we can prepare the inlet outlet table and then calculate the unknown stream. And then finally, we can solve this delta H or specific enthalpy. Okay, let's take a look to the example here. We have the furnace. So that's mean the combustion occur here. So these are the reaction and the heat of reaction is given here. So the question is how much heat is given off by the furnace. So since the balance, the material balance is performed here, so we may proceed to the next step, which to choose the reference state for the energy calculation here. Usually, we can choose at 25 and 1 atm. Okay, and then after that, in case we choose the one reaction, we can use this formula to calculate the extent of reaction. And then we can prepare the inlet outlet enthalpy table here. So we have about 5 substance here. So you may put a reference for each substance. So at 25 and 1 atm. Then after that, you can from the enthalpy, example H2 here. Here is equal to 0 because the temperature at 25 degrees Celsius. So no need to consider the enthalpy for propane here. And then for H2 here, okay, so from 25 degree to 300, so you may refer to the heat of reaction at this temperature. You can get this value. Same goes to the rest. And then for water, so it has changes phases and also the temperature. So you may perform this. So start from this reference temperature to the boiling point of water. And then we have the heat of vaporization, and from 100 to 1000 we can get this value. Okay, the CP you may refer to the reference table here, and then finally you can fill in all the unknowns variable, and then after that you calculate the extent of the reaction here based on this equation. Input minus the number stoichiometry or number of mole from the output of a species A. For any species that can be calculated, or here maybe you can choose the oxygen, so 100, and then you can get the extent of the reaction here. Then you may determine the heat of reaction, the given in the question, and you can solve here. Finally, we can get the enthalpy. Since the energy balance or Q here, by eliminating this, okay, the delta H equal to Q. So the final answer is 1.26 power of 5 kilojoule per second or kilowatt. Okay, the second method is to choose the heat of formation. So previously we learned about the heat of reaction, and then this is related, or if we use the heat of formation method. So the first thing is to complete the balance. We done this because all the information given in the question, and then choose reference state for energy calculation at 25 degree and 1 atm. Okay, for the reacting species, we must find their elemental species at standard condition. Okay, these are the list of the substance, and then we may prepare the inlet outlet enthalpy table. Okay, example here for propane, we can determine this from the reference table. Then example from this goes to the oxygen, nitrogen. So this is the elemental given in the table as well. Then you can perform this for CO2. Okay, because CO2 we have this heat of formation at 25, but since the temperature at 1000, so we may proceed to perform the CP here. And then same goes to the water. Okay, bear in mind for heat of formation, there is no more heat of vaporization process because we base on the element or the formation. So this information you may refer from this reference table, the value, and then you can get the final values here. Finally, we may calculate the enthalpy or the specific enthalpy here equal to the Q or rate of heat.